Assalamualaikum and selamat sejahtera. Physics Form 4 Wave 5.4 Refraction of Wave. Okay, I am Cikgu Suriyati Yusof from Sekolah Menengah Sains Muzaffar Shah Melaka. Our topics today is 5.4 Refraction of Wave. The learning standards. First, describe refraction of wave from the following aspect. Angle of incidence, angle of refraction r, wavelength lambda, frequency f, speed v, direction of propagation of wave. Second, draw ray diagrams to show the refraction of wave for two different depths. Third, explain natural phenomena of refraction of wave in daily life. Fourth, solve problem involving refraction of wave. Look at this picture. This picture is taken in Imswain, Morocco, showing the curve. So here, the curve wavefront of the sea when approaching the shoreline. Okay, the curve of the wavefront is caused by the phenomenon of refraction of wave. Here is another picture. Show a seawater wave traveling towards the shore. Observe that the wave and compare their shape when they are away from the shore and when they approach shore. Okay, so wave refraction causes wave fronts to parallel the shape of the coastline as they approach the shore. So we start with activity 1. So a square glass slab is placed in the ripple tank so as to create different depth of water. So this is the deep area. So above the glass is produced shallow area, and here is again the deep area. So the wave coming from right to the left, the deep area, shallow area, and move to the deep area again. So first question, observe diagram, compare the frequency of the water wave in deep area and shallow area. Explain your answer. So the frequency is the equal because we use the still same motor to vibrate the vibrator. Okay. Compare the wavelength in deep area and shallow area. So as we can see in this diagram, so the deep lambda in deep area is longer than lambda in the shallow area. Okay, I'm supposed to be lambda. So deep area is bigger than shallow area. Compare the speed of wave in deep and shallow area. Okay, so the speed in deep area is faster than in shallow area. Okay, relate the depth of water to the speed of water so that it will be directly proportional. Relate the depth of water to the wavelength of the wave, directly proportional. So relate the speed of water wave to the wavelength of the wave, so it will become directly proportional. Okay. So what is the refraction of wave? The refraction of wave is the change in direction of propagation wave caused by the change in the velocity of wave when the wave propagates from one medium to another. So we are going to study three types of wave: water wave, light wave, and sound wave. So for water wave, speed of water wave is influenced by depth of water. Speed of light wave is influenced by optical density of medium. For example, light travel from water to air, so different density. And for the sound wave, speed of sound wave is influenced by the density of air, hot air and cool air. Okay, so cool air is denser, hot air is less dense. Now we write an equation for refraction of wave. Okay, so we have the formula V1 equals to F1 lambda 1. Let's say this is the deep region. Okay, and for the shallow region, V2 equals to F2 lambda 2. Now we have F1 equals to V1 over lambda 1. Same with F2 equals to V2 over lambda 2. And we notice that the both lambda for deep region and shallow region are equal. So the equation is equivalent to V1 over lambda 1 equals to V2 over lambda 2. So this will be the equation for the refraction of wave. Okay, now we look at the characteristic, we have three things here: angle of incidence and angle of refraction, I and R, speed, wavelength, and frequency. Remember the formula: V equals to F lambda. Now, water wave passes from deep to shallow. Okay, deep to shallow. I is larger than R, speed decrease. Where else water passes from shallow to deep. Speed decrease, wavelength also decrease because both are directly proportional. Frequency stay unchanged. Okay, when water passes from shallow to deep water, increases, and wavelength increases, and frequency remain unchanged. Okay. So how does the direction change? Okay, we have two type of change of direction. First, how does the direction of wave change when passing from deep to shallow water? From deep to shallow, when travel from deep to shallow, the speed will decrease, will slow down, so it will move towards normal line. Okay, so it will refract towards normal line. What happened? The direction of wave change when passing from shallow to deep water. From shallow to deep, the velocity will increase, so it will refract away from normal line. Okay. So always remember, if the speed is slower, therefore it will refract towards normal line. If the speed is faster, it will refract away from normal line. This is the activity 2. This is the experiment that we can do in the lab. To study the refraction of water wave by using a Ripper tank. So this is a Ripper tank. This is the perspex plate or the glass plate that will determine the depth of the water in the Ripper tank. Okay. Okay, so this is again another practice for you to draw the refraction of water wave. So again, shallow, so we draw a straight line here. So this is straight because always parallel with the normal line, so go straight, and then same thing when go out in the deep region again. So now we draw the wavelength. This is smaller in the shallow region, which is perpendicular to the direction of propagation, and outside in the deep region, lambda is longer again. Okay, now here we have a boundary here. Here is an angle. So what we do, the first thing is we draw the normal line, always perpendicular to the boundary, and then it will refract towards normal line because deep to shallow, slow down. Now out again we draw normal line. Now from shallow to deep will be refract away from normal line, like this. Next we draw the wavefronts, okay, so which is perpendicular, okay, to the direction of propagation at smaller lambda, and in the deep region, so it will be perpendicular to the direction, and it will be longer than in the deep region rather than the shallow region. Okay, we have another one. So this straight line, you go straight and then draw the normal line, and then we decide shallow to deep will become away from normal. So away should be downward, away from normal line. Draw the wavefronts, okay, smaller lambda and perpendicular longer lambda. Okay. Now we have the shape of glass like this. This is like convex lens. This is like concave lens, right? So convex lens always, if refraction occur, always what we call converge the wave, and this is diverge the wave. Okay. So it will be like something like this. Okay, so it will converge to like a point. This is a focal point. So it will diverge outward like this. And lambda in the shallow region above the glass is shallow, means lambda is shorter, and lambda is longer. Okay, now we do one exercise. Okay, number 1. Plane wave has a wavelength of 2 cm and a velocity of 8 cm per second as it moves over the surface of shallow water. When the plane wave moves into an area of greater depth, its velocity becomes 12 cm per second. What is the wavelength of the wave in the area of greater depth? Okay, so remember the formula. So we have lambda, lambda 1 2 cm, shallow region, lambda in shallow 2 cm, V is 8 cm. Now go to the deep. So lambda 2 we have to find, and we want to, given that V2 is 12. Okay, so what we should do is use the formula. Okay, this formula, and put all the that data given. So we want to find lambda 2, and we calculate that lambda 2 equals to 3 cm. Okay, next question, we are given this diagram. So the water wave is one area from P to Q, different depth. Calculate the speed. So which one is deeper? So here lambda is longer, so P is deeper, Q is shallower. So calculate the speed of water in Q. So P is 18, so we do not know V. What we have to find lambda. So lambda 1 is, this is 1 lambda, 2, 3, 4 lambda, 12 divided by, 1, 2, 3, 4, 12 divided by 4 is equal to 3 cm. Okay, here we have, okay, lambda 1 equals to 12.5 divided by 4 is 3 cm. Here we have smaller lambda. The length is still 12 cm, but we have 1, 2, 3, 4, 5, 6, 7, 8 lambda. So 12 divided by 8 is 1.5 cm. So use the formula V1 over lambda 1. V1 is 18, lambda 1 is 3, V2 is we need to unknown, and 1.5. So we get the formula calculated, we get 9 cm per second. Okay. Okay, question 3. Diagram shows a water wave move from region P to Q. Which region is the shallow region? Q. Okay, so region Q is the shallow region because the wavelength are smaller. Okay. Compare the speed and frequency of the water wave in both regions. So speed in P is bigger, is faster than speed in Q. Frequency equals, and lambda P should be longer than Q. Okay, here we have another question. Okay, you are given the shape of the river tank. It's not in the depth is not equal. So it's moving from Z to X, right? This is the vibrator from Z to X, sorry. So Z is the deeper, this is the shallowest. Okay, so it will go something like this lah. So Z, so all straight lines because this is plane wave. Okay, and this is longer, and X is the shorter wave. Okay, now we try to discuss the natural phenomena of reflection of wave. Okay, so we will try to explain just now why the seashore is parallel or follow the shape of the the shoreline. Okay, so this is the Cape Bay, and in the middle, in the opposite, the wave coming is in the straight line, okay, plane wave. Then when we approaching the shore, it will follow the shape of the shoreline. Okay, so why the wave become closer to each other and follow the shape of the shoreline when they are approaching the beach? So the answer is the water wave travel from deep to shallow region, from deep to shallow. Second, the speed of the wave decrease, so speed will decrease, and the water wave reflected towards normal line. Okay, so that's the reason why it follow the shape of the shoreline. Now, why the water at the Cape has high wave? So the water at the Cape, so this is the Cape. So more energy is converged at the Cape area. So water at the Cape has high amplitude, so high energy. Why the water at the bay is calm? So normally at the bay is calm because first, the energy of the water wave spreads to a wider area. So the wave come here and it spread to wider area. Therefore, the amplitude of the water wave is low. So the water at the bed is calm. Sound wave. Okay, compare the refraction of sound wave during warm day and cold night. Compare the speed of sound wave in warm air with cool air. Why? Okay. So the speed of sound in warm air is greater because the temperature in warm air greater. Air molecules gain more kinetic energy and it will move faster. Explain why sound cannot be heard over a longer distance on a hot day. Okay. So sound waves travel faster in warm air. So on a hot day, the layer of air near the surface to be warmer. So hot day. Okay, this is a hot day. The layer or the air layer near the surface of Earth is warmer. So you move outward. As the sound move outward, it will change the temperature will change to cooler air. Okay, so you move from hot air to cooler air. So sound travel from hot to cool air. So the speed of sound decrease. So when the speed of sound decrease, as we look here, so this is the boundary for hot and cold. This is the normal line. So it will move towards the normal line. So it seems that it will move reflected towards normal line, and the sound reflected away from the earth. So this is the man here. You cannot hear the sound because the sound is moving away from the earth. Okay, same thing like this picture. Okay, now next question. Explain why sound can be heard clearly over a longer distance on a cool night. So during night, what happens is the air near the surface is cooler. Then when the sound move outward, it will move from cool air to hot air. So now we have cool air to hot air, right? And this is the boundary, and here is normal line. So whatever, and now the ground cools, air layer near the ground colder. So sound travel from cool to hot air, so the speed of sound increases. Therefore, sound reflected away from normal line. So it's normal line, so it's reflected away from normal line. So sound wave moving toward the earth, so it will moving toward the earth. So that's why observer hear sounds which are louder here. Okay, at night. Okay, so that's it for our lesson today, refraction of wave. Thank you for listening my lesson today. So hope to see you again. Assalamualaikum. Bye.